The natural world is full of the most amazing materials. Tougher than steel, finer than our best optics. And how nature builds with these materials is even more extraordinary. In the last few years, scientists have begun to look at nature with new eyes. And what they're finding promises new materials. Warmer, smarter, stronger, more eco-friendly. Technology, working with nature to build a new and unexpected world. For thousands of years, people have been making use of nature's raw materials. In the early days, we relied on them for our homes, our clothes, just about everything. But humans aren't the only creatures to use natural building materials. Here in northern Namibia, a pair of hornbills have used mud to make their nests secure. The female has been sealed into the nest hole behind a wall of mud, leaving just a small gap, big enough for her mate to pass food to her, but small enough to keep out all predators. Mud is a really popular choice when it comes to building. Throughout the tropics, colonies of termites use mud to produce complex nests, some standing up to 3 meters tall, full of intricate tunnels and chambers. To create these incredible structures, termites mix different types of mud to do different jobs. Mud mixed with saliva and feces dries to create an outer wall as strong as concrete. People have also been using mud for centuries and have found, like termites, that mud mixed with various other substances produces building materials with different properties. It's a versatile building material, and it's been used to create some extraordinary things. The great Mosque in Jannah, in Mali, the world's biggest structure made of mud bricks. This impressive building is made of sun-dried mud bricks held together with a mud mortar, then coated with a plaster of smooth mud. The mosque is nearly 100 years old and will last for centuries more if properly maintained. The Malians and termites hit on the same solutions to building by trial and error. But when biomimetic scientists look at natural materials, they're hoping not just to copy nature, but to understand the basic principles behind nature's success and build on that to invent completely new materials. And that's exactly what's happened with wood. an even more versatile material than mud. Wood is made of long, tough fibers and is used by wasps to make their nests. Chewed to a pulp and mixed with saliva, they turn it into a kind of cardboard. It's tough, it's good insulation. In short, an excellent building material. And the wasps are surrounded by it. Wood is everywhere, just for the taking. Which is why it's been so useful to us. It's been used for everything, from Stone Age monuments, to houses and bridges, to carts and boats. It's not surprising that wood was the foundation of our world. Unlike mud, wood is a complex, sophisticated material. It has to be, because it supports nature's largest structures. On the slopes of the Sierra Nevada mountains in California are the biggest organisms ever to have lived. These sequoias tower up to 80 meters above the forest floor, though some reach as high as 100 meters. These massive trees weigh around 1,400 tons, and each one contains enough timber to build 120 houses. It's taken them more than 2,000 years to get to this size, and that's only possible because wood is such an amazing material. The fibers that make up wood are long, tiny, hollow tubes that carry water from the roots to the leaves, the tree's plumbing system. Wound around the tubes in a helical pattern, tiny fibers of cellulose are embedded in a kind of resin. It's this arrangement that gives wood such amazing properties. In particular, this structure makes wood very resistant to cracking, crucial if a tree isn't to lose its branches in every storm. If the force on a branch is enough to start a crack, the crack just runs around the spiral fibers, which absorb its energy and stop it spreading any further. This makes wood very hard to crack, which is why we still use it today as a building material. But can we do better than nature? At the University of Reading in the UK, scientists are studying wood's performance in detail. Different kinds of wood are tested to destruction. Driven by a high-pressure air system, a metal rod is rammed into a block of wood. As the scientists identify which kinds of woods are the strongest. Based on their results, they came up with a revolutionary new material, a kind of artificial wood. It's made from resin with fibers running through it, and so mimics the pattern of wood, with many of its tough properties. So much so, it's one of the toughest materials ever made. It's yet to be put to practical use, but it's strong enough to make bulletproof armor. But wood is more than just tough. It can also be smart. Like the wood in tree trunks, the woody scales of pine cones are made of stiff fibers embedded in a resinous substance. But these fibers lie in different directions in the top and bottom layers. When the scales dry out, the bottom layer shrinks more than the top, which makes the cone open and release its seeds. One designer is looking at a clothing fabric that works in the same way. As the fabric starts to get damp from sweat, sections of the fabric lift up to provide ventilation. This is true biomimetic thinking, not merely using natural materials, but understanding how they work and applying the principle somewhere else. But this kind of thinking isn't entirely new. Natural designs inspired some of the Victorian age's greatest architecture. In 1849, botanist Joseph Paxton had to build a new and bigger greenhouse for his ever-expanding Victoria lilies. These plants produce enormous leaves, up to 2 meters across. Hence Paxton's problem. But those same leaves held the solution to his problem. They're supported by a complex series of ridges and struts, and Paxton saw he could use the same arrangement to support a large roof span over his new greenhouse. He showed just how strong these leaves were in a most unusual way. They can easily cradle a baby. Paxton was so confident of the leaf's strength, he entrusted his young daughter to this Victorian equivalent of a waterbed. And when full-sized, these leaves can even support the weight of an adult. He built his greenhouse on these bio-inspired principles. And it was so successful that he went on to build even bigger structures, like the magnificent Crystal Palace. Built in London for the first World's Fair in 1851, the Crystal Palace was a technological marvel of glass and iron, 33 meters high and covering about 7 hectares, all thanks to a plant from the depths of the Amazon rainforest. What the lily shows is that it's not just the material used that makes it tough. It's also the details of how it's constructed. And that's equally true of the materials that make up animals. When the fall comes to the Rocky Mountains of North America, nature puts on a dramatic demonstration of one of her most remarkable materials. At this time of year, male elk gather up groups of females ready to mate, but they have to defend these harems from rivals.